Wind turbines have become a familiar feature on our landscape. We've grown used to those constant turning of those blades in the distance. But have you ever wondered what happens to those blades when the turbines are eventually decommissioned at the end of their lifetimes and taken down? Let's take a look inside one of these blades. Blades are made of a composite material, and a composite is a magical mixture of two different substances: a plastic resin and woven glass fibers. No other type of material can confer the extraordinary strength and lightness that's needed for these huge objects. But there is a problem. This magical marriage of two different substances, breaking up is never easy. When we try to recycle composites, we have a problem. It's hard to extract the plastic resin from the textile of glass fibers. So we take the approach that we can't disaggregate these two materials. The manufacturing process of composites is hard to reverse. Up to now, the standard solution for dealing with wind turbine blades at the end of their lifetime was to simply landfill them, to bury them in the ground. This iconic image shows only about 200 blades, taking up about 2,000 square meters of landfill. And that's only a small proportion of the blades that are going to be decommissioned in the next decades. No one wants to see thousands and thousands of blades like these piling up in our landfills. Is there a better way to deal with them? Well, what about grinding up the blade material, shredding it? Maybe we could use it as fillers in a construction project. But the problem with shredding and grinding is that these processes are intensive in terms of energy and in terms of consumables. And what they're basically doing is that they're taking a high-value product, an engineered product, a wind turbine blade, and using energy and consumables to transform it into something that has a very, very low value. The world is full of fillers derived from different types of waste materials. And all these fillers are just looking for places to go. They're looking for things to fill. Is there a better way? The waste hierarchy gives us a system of classifying end-of-life solutions. So wouldn't it be great if there was a solution for end-of-life wind turbine blades that was at the top of the waste hierarchy rather than being firmly rooted at the bottom like landfill? Several years ago, researchers from Ireland, from Northern Ireland, and the USA got together to try to address this problem of end-of-life solutions for wind turbine blades. We'd never met before in person. So one sunny morning, I'm from Ireland, by the way, and yes, we do have sunny mornings sometimes in Ireland. One sunny morning, I left my office in the university, I cycled down the hill, over the bridge, through the gates in this picture, and I met my two newfound collaborators. We soon got talking about the problem of what to do with these blades. We all shared an interest in sustainability, and none of us was a fan of the downcycling solution, shredding or grinding. But we were all engineers, and we quickly realized that this problem wasn't going to be solved by engineers alone. So we formed a community called Rewind, and we invited into Rewind the best experts that we could find from architecture, from community engagement, from geographical information systems, in order to tackle this multidisciplinary problem. The vision of Rewind was to find repurposing solutions near the top of the waste hierarchy rather than dealing with low-value solutions like landfill. We wanted to, furthermore, not just find solutions that were technically feasible, but we also wanted to find solutions that were socially feasible, environmentally feasible, and economically feasible. So we got together in a room and we brainstormed about 50 different ideas. And we assembled them into a blade repurposing atlas. This was great, but these were still just ideas. Would they work in practice? Would the blades actually be strong enough and durable enough to fulfill these new purposes that we had just imagined for them. So there was a problem. They were just concepts. We didn't have any evidence yet. So the next part of our journey was to try to go further, to go deeper, and to consider the evidence basis. Blades are hard to work with. If you want to repurpose, you have a problem. Blades are curved, they're tapered, they have a complex geometry. Furthermore, no two blades, we found, are exactly the same, even if those two blades are from the same model of wind turbine, and even if those two blades are actually taken from the same turbine. So, this is what we did. First, we had to find a blade, take it down, 3D scan it to figure out its fiendishly complex external geometry. That was progress, but the internal geometry of the blade isn't visible from the outside. So, next, cutting, drilling, looking inside the blade, burning it to burn away the plastic and look at the structure of the composite mat fibers. Our team even built an entire bridge with the purpose of testing it to destruction. Now, for the non-engineers in the room, testing to failure or testing to destruction is a nice phrase that we like to use for breaking stuff. So, we piled on 33 tons of concrete blocks onto this bridge, but the test to failure was a failure. We couldn't break it. So with this, we had demonstrated, we provided the technical evidence that yes, blades are strong enough and durable enough for repurposed structures. This bridge is on a greenway, a cycle and pedestrian route near Cork in the south of Ireland, where I am from. What's special about this bridge is that the two main load-bearing elements of this bridge are repurposed wind turbine blades. The blades replace concrete and steel, conventional materials, and what this means is that this bridge has a lower overall environmental impact and a lower carbon footprint than a conventional bridge. Let's look at the past lives of these two blade bridge supports. These blades have been on quite a journey. First, on a wind farm, on a wind turbine in Denmark, providing energy. Then they were moved to Ireland and on another wind turbine, providing energy, and then cast aside, left unloved in a yard for about 20 years until they found a new lifetime and they found a new purpose. They went from providing sustainable energy to now providing sustainable transport for commuters, for tourists, for families. We had done it. We had shown that the technical feasibility of making something new out of repurposed wind turbine blades was possible. However, that wasn't the only part of our journey. We still had to think about the environmental feasibility and the social feasibility. So we carried out two life cycle analyses of blade bridges versus conventional structure bridges, and of repurposing versus landfilling or incineration as ways of dealing with end-of-life blades. And repurposing always came out on top. But what about people? Would people accept structures, artifacts made out of these huge, decommissioned wind turbine blades, waste in their environment? We carried out further research with local community groups, and the answer we got was a resounding yes. The future sees larger blades, we're going to see stronger blades, and we're going to see more blades. The little blades that we used in our wind turbine bridge are 14 meters long. We're going to see much larger blades in the future. The blades you see here are 125 meters long. That's 9 times longer than the little blades we had already. So, wind turbine manufacturers who are designing new blades, they're designing them to squeeze every last drop of aerodynamic performance out of the blades. but they also need to design them from the outset with repurposing and recycling at the end of their life in mind. And that may take 20, 25 years. They also need to commit to release the design details of these blades in order to help the future community of creators, of inventors, and designers to deal with these blades. In the nearer future, in the next 5 to 10 years, we're going to see longer blades coming out. We're going to see 40-meter blades coming out of service very widely across the world. And these will allow us to build bigger structures. So with a 40-meter blade, we can build a bridge of 25-meter span. We can build a telecommunications mast of 30-meter span. When these huge whopper blades from Mingyang in China come out of service in 2045, what will happen to them? They could become parts of stadiums. They could become highway bridges. Maybe they could become coastal protection barriers against rising sea levels. So, what I would like to see is a blade repurposing superstore. A blade designer can browse, either physically or virtually, with a design purpose in mind, and pick out the blades that best suit their application, based on their specifications, based on their size, based on where they are, and based on when they will come out of service. What we also need is reform in building regulations. The construction industry emits 1/4 of global greenhouse gases. And around 1/3 of that is coming from raw materials processing. It's coming from extracting the steel and the concrete that we use to create our infrastructure. Wouldn't it be much better if instead of perpetuating this cycle of extract, fabricate, commission, operate, demolish, dispose, that we used the high-precision, high-value manufactured products that we already have in existence? So I would like to see 3 deep shifts. We've seen the first one. The first one is flipping our thinking about wind turbine blades at end of life, from waste to resource. The second one is that we need a change in these building regulations that allow us to use repurposed materials in new structures. That's going to need radical reform in building codes and building regulations so that repurposing becomes the norm. And the third one is the blade superstore, where people can go and find the right blade for the job. So with these 3 deep shifts, we can see a pathway for the future. Repurposing is going to continue to test our ingenuity. But in a world that's faced with a climate crisis and finite resources, repurposing is the only choice we have as the creators, the inventors, and the designers of the future. Thank you.